Ainda estamos no quarto hora académico.
Eu fui guardando Boa tarde a todos aqui presentes. Uma grata missão que tenho enquanto reitor é presidir a estes eventos, aos quais eu atribuo, como já disse anteriormente, até mesmo nesta sala, elevada importância. São atos importantes para a construção de uma comunidade e são momentos que nos juntam a todos em torno de pessoas que, pelo significado daquilo que aqui construíram, ficarão para sempre nas nossas memórias. Há pessoas aqui, nesta sala, o professor Joaquim Vieira, certamente um deles, cujos percursos pessoais se entrelaçam tanto com as trajetórias institucionais que é difícil distinguir, às vezes, o que é um e o que é outro. Contudo, esses percursos tocam sempre em dois pontos importantes, um dos quais celebramos hoje. O momento de chegada à instituição, muitas vezes não é o verdadeiro momento de chegada, porque a pessoa já cá estava antes, embora noutro vínculo, embora com outra ligação, e às vezes a data que eu tenho nos documentos não corresponde à data verdadeira em que a pessoa começou a ter impacto na universidade. E o momento em que ela, por razões mais diversas, às vezes aposentação, às vezes porque vai para outra instituição, desta instituição se afasta. Um momento e outro são sinais, são momentos muito importantes no nosso percurso, quer para a nossa instituição, quer para a pessoa. E acho que fazemos muito bem, o Departamento faz muito bem, o Sr. Diretor sabe que contará sempre com o meu apoio para isso, faz muito bem em celebrar, em juntar, a propósito dessas pessoas e destes eventos, pessoas que partilharam esses percursos e que podem certamente, com eles, rever-se e rever a própria instituição. Eu não vou falar do percurso nem do currículo, porque acho que neste momento é escusado fazê-lo. Se estamos aqui neste momento é porque reconhecemos todos esse currículo e esse percurso. Deixaria para o Sr. Diretor algumas notas mais pessoais acerca da pessoa que hoje, em certa medida, dá esta sua última aula, que eu espero que não seja bem uma aula e seguramente não seja a última. E esse era o meu mote para terminar. Este momento formal de encerramento de uma atividade, a propósito, por exemplo, de uma aposentação ou de uma jubilação, que não seja o último momento. A pessoa pode formalmente não poder não voltar a dar aulas aqui, mas acho que quem teve sempre a porta aberta seguramente não a vai fechar hoje a todos. Pode continuar a ter um papel importante com os estudantes, pode continuar a ter um papel importante de mentoria, de conselho, de colocar a sua experiência, como tem feito sempre até aqui, ao serviço dos outros e da universidade. E por isso acho que é um momento em que nós celebramos todos juntos um percurso, mas também uma nota acerca do futuro e não um ponto final. Muito obrigado a todos pela vossa presença. Sr. Professor Joaquim Vieira, tenho aqui uma lembrança desta altura e deste momento, que tenho muito, muito gosto em entregar. E mais...
Bem-vindos à última lição do professor Joaquim Vieira e desde já tomo a liberdade de fugir ao protocolo de cumprimentos, uma vez que estamos num encontro entre familiares e amigos. Creio também que tiveram a oportunidade de ler uma breve resenha da carreira do professor Joaquim Vieira, que foi colocada no jornal online, que anunciaram esta aula. Vou apenas destacar que o professor Joaquim Vieira licenciou-se em Física pela Faculdade de Ciências em 1976, Faculdade de Ciências de Lisboa. Mais tarde doutorou-se em Ciências dos Materiais em 1981 em Leeds, Inglaterra, e é professor catedrático da Universidade de Aveiro desde 1999. Um currículo extenso, só destaco que teve uma participação relevante em órgãos da Universidade, nomeadamente a presidência do Conselho Científico e os cargos de pró-reitor e vice-diretor do CISECO, entre muitas outras funções. Bom, para mim é uma feliz coincidência eu neste momento ser o diretor do departamento, porque vou ter o palco por minha conta por alguns minutos neste dia e revelar um pouco daquilo que o professor representou na minha vida. Primeiro, começar por dizer que, tal como a complexidade que todos conhecemos e que associamos ao professor Joaquim Vieira, também a minha interação teve nuances muito diversas. Começando por momentos em que hoje em dia o meu coração não aguentaria. Por exemplo, nunca mais me esquecerei de uma das diretas passadas em casa do professor, neste caso de uma sexta-feira para um sábado, a escrever um projeto para a então GNICT, antecessora da FCT, tarefa que terminou depois em direta, depois das 11 da manhã de sábado, e nós, seguida da odisseia, que foi fazer uma viagem de carro até ao aeroporto do Porto, para conseguir colocar no último correio a carta, lá o projeto, que era ao meio-dia e meio, o último correio, e portanto conseguiu a carimba dela no último minuto, no último segundo, na última hora, no último dia da entrega de projetos. Devo dizer que, a meio dessas diretas, dava-lhe a fome e nós íamos ao Neptuno comer umas bifeiras às 3, 4 da manhã. Mas isto foram várias noites deste estilo. Alguns colegas meus foram passados por algo semelhante também. Ou então os calafrios que eu senti quando o professor Joaquim Vieira, meu orientador de doutoramento, me entregou a tese corrigida para aí em 90% das palavras. Atenção, não foram correções científicas, porque posso dizer com orgulho que sempre senti que o professor me respeitava e confiava no meu trabalho e na minha qualidade científica. Era mais uma questão de estilo, porque ele tinha vindo de uma escola anglo-saxónica e era um portuguesinho com um discurso ainda meio barroco e, portanto, todas as palavras foram todas riscadas. Mas o contraponto foi precioso. O professor Joaquim Vieira deu a oportunidade à minha vida, que foi uma bolsa de doutoramento fora da caixa na altura. Isto é, alguém que estava a trabalhar numa empresa e quis mudar de vida, ou seja, quis mudar do certo para o incerto. Felizmente tudo correu bem, com a orientação do professor, só podia correr bem. Durante o meu doutoramento aprendi a pesquisar, a organizar a bibliografia, a montar experiências em laboratório, medir corretamente as propriedades dos materiais, abordar numericamente os resultados, confrontá-los com a literatura, ou seja, tudo que nos pode aproximar da excelência em investigação. Mas todos estes ensinamentos foram sempre associados à boa disposição e ao otimismo do professor Joaquim Vieira, a par de um elevado grau de exigência, rigor e profundidade. Mais tarde, como colegas, continuámos a nossa colaboração na elaboração e execução de projetos, na coordenação de pós-graduações e nas diversas interações que os nossos cargos iam exigindo. Dito isto, o meu encontro com o professor Joaquim Vieira resume-se a 2 palavras e um ponto de exclamação. Aprendi muito. Ao Joaquim Vieira, meu colega, a minha profunda gratidão por ter sido meu professor e meu amigo.
Corta um bocadinho, assim. Ok. Já estou um pouco destreinado. Estava a ouvir as palavras do Rui e não tinha bem certeza se era eu. Por isso era feito. Já estou um pouco destreinado. Estava a ouvir as palavras do Rui e não tinha certeza que era eu, porque já estou um pouco esquecido. e arriscar uma aula sem trazer apontamento, como estão a ver, é só porque desde a primeira aula que dei nesta universidade esquecia-me sempre dos apontamentos. E está ali o António Moreira. De qualquer modo, formalmente, cumprimento na pessoa do professor Paulo Ferreira, reitor, toda a nossa academia, os que não estão aqui, vejo aqui colegas de outros departamentos, vejo pessoal de outras carreiras também que quis aqui visitar, amigos que foram ficando daquilo que o Rui e o Paulo sumarizaram. E na pessoa do Rui, cumprimento aqueles que são mais chegados, até o Henrique diz que já cá ocorreu, e sei que foi ele que inventou uma parte deste edifício, que ainda tem lá os rascunhos, e tive a guardá-los. Cortarmos ali cinco gabinetes, que agora fazia muita falta ao Rui. Passando disso, tenho que confessar que fiz 2 erros na preparação da lição. Primeiro, por causa de uma aposta com o Martinho, não sei se me está a ouvir, fiz mal. Segundo, eu sei que não precisava de ser mal, mas fiz mal. Segundo, posso-me esquecer de ir citando aquilo que é a minha intenção, factos e acontecimentos que me ligam às aulas e o trabalho aqui feito a todos vós. Forçosamente, primeiro, queria agradecer também a presença da minha mulher, da minha filha. A minha outra filha foi vítima do Covid, nada de importância, já estará a melhorar, mas não se pode deslocar de Lisboa para aqui, coisas que nos temos que habituar. E digamos que a ciência ganha outra cor quando a gente começa a precisar dela. E a gente muda muito de percepção daquilo que é o trabalho científico quando começamos a precisar dela. A segunda questão, se não me esqueci do que estava a pensar, vou ainda justificar o título e uma correção que tenho que fazer a alunos que estiverem aqui sentados, se eu tiver aqui algum aluno do curso do ano passado, do mestrado, pós-termíssima aula é um erro, mesmo para um professor que fez 7 anos de latim. Pós-termíssima classe está correto, aula é um corredor, e como eu não gosto nas coisas formais de trazer erros, peço, aliás, ao Pedro que vá apanhando alguns erros que me possam ter escapado no PowerPoint. E, portanto, foi uma brincadeira nesta sala em que eu disse, vocês são felizes, vão ter a sorte de assistir à minha pós-termíssima aula, e uma aluna, mais ou menos ali, pós-termíssima quê, professor? Pós-termíssima aula, é latim, pronto. E depois ficaram todos entusiasmados, tal ponto que eu tenho ali uma garrafa que eles me ofereceram no fim da disciplina, nunca me tinha acontecido. Para nós abrirmos hoje, e se tiver ainda algum aluno dessa turma, ele terá o cuidado de fazer a prova, se eu vinha, é de facto bastante bom, eu preciso que sim. Segundo, vou mudar de linguagem, porque estão vários alunos estrangeiros a ouvir, e portanto, porque preparei tudo em inglês. Eu espero que a instituição não se ofenda por eu não usar a língua de Camões, ou poderei voltar para a língua de Camões rapidamente. Já gastei meia hora. Primeiro, pôr o que é numa aula neste momento da carreira. Não sou daqueles que tenham muita investigação para contar, eu fiz sempre o mesmo. Não sou daqueles que tenha muitos sucessos para contar. Tive o meu sucesso nesta casa e outros. Mas estava a ler, de facto, um trabalho que de repente me deu um mote, seguindo um pouco aquilo que o Jorge fez. Porque não pôr um pouco de poesia na ciência, pôr um pouco de poesia na carreira académica. O trabalho traduz um pouco a minha reação e o próprio título. O autor, o Fernando Miguel Bernardes, é formado também na nossa área e põe a questão, no fundo, a nossa eterna dúvida que nos empurra para andar todos os dias a pensar nos assuntos que não percebemos, incluindo o trabalho científico, que nos faz chegar a velhos sem andarmos por isso. E às vezes, como aconteceu ao desgraçado do Arquimedes, que gritou para o soldado romano: não pises essas linhas, e foi a última coisa que dizem os livros que ele disse. Também teria morrido nesse dia se tivesse ido para as muralhas de Cartago, e porque não sobreviveu ninguém tanto quanto dizem os historiadores romanos. Ok, não preciso traduzir para inglês, é apenas para acrescentar, para quem não está a ver em português. Obviamente, estas questões são muito antigas e há muitos mitos na nossa civilização em torno do conhecimento e do vício do conhecimento. I will spend now some time with some questions that since I started studying were always some kind of magic for me, and one was this theorem of Pythagoras. Happy enough the guy was killed. Otherwise you would have much more theorems to study in the 20th century. Not because of the magic of having to do so many calculations just with this simple rule of adding 2 squares to make a third. Really, some research done before, it exists 4,000 years ago, It was a very nice, I was born in a village with farming and sometimes to dividing properties. It was a very nice to make a square line to separate two properties after the flutes. And I discovered that there is many documents on this time, and it was compulsory in the Middle Age for a professor to become lent in mathematics to present a new demonstration for the Pythagoras theorem. So it is really something. It is not easy to demonstrate after all, and I collected because that's really a matter of curiosity. Curiosity drives research most of the time, and there is a concave theorem that makes more or less exactly the same as later, I think it was Leonardo. Yes, he also invented this demonstration. And because this is just for documentation, not for me to explain here, I challenge you to go back and try to see if you still remember how we do the demonstrations of that. It is important when we do dissemination of science, when we call attention to the young generations of the abstraction that we have in science, and the abstraction is a real matter that I choose. Then there was these theorems on similarity of triangles with hands all together. Yes, this is really a matter not so easy. Or even before we have Leibniz and differential in calculus to make the demonstration that there was acceleration in a laboratory experiment. Okay, Gerard, why I'm here today? Eventually because my professor of chemistry asked me at the age of 14, Joaquim, it seems that you have some talent for these laboratories. Can you take care of it? I do not have time to prepare the experiments for your colleagues. It was a very fine laboratory. All the things we need for up to the seventh year of the high school. And I'm happy to acknowledge, not just that, as in many schools, as Frad is saying, to see it packed 5 years ago. Still some of the pieces of that laboratory of my memory exist in the same seminary of Almada, in the very top, but it was packed in a corner of a corridor. It was really a treasure, and I learned a lot on these concepts. I did experiments. It was with a tick-tack, 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 tick-tack. I was told that Galileo did it with a glass of water, and it seems feeling 1, 2, 3, okay, from a tap water somewhere. And I was also told that Archimedes did not demonstrate that there was a specific mass, but he demonstrated that there was a specific volume. Okay, because he had something filled, but one thing, but another took the difference of volumes for that. But anyway, things change really when we start going to relativity. It was one of these difficult subjects, and as Rui warned some students later, not a few years ago, you are in a corner because this professor is terrible, likes mathematics, so anyone that he did not make the comment, but the comment, the author is here, Rui. Okay. So you have to learn mathematics. I have really a difficulty. If I cannot make a plot, calculation, equation, I do not understand. So there is one of the students there, okay, and Daniel, he is suffering of this disease. But why that? Really, one of the more difficult things for me was that guy traveling in the train with the Michelson interferometer and the other one outside, and why do they take the same velocity for light? Okay, I knew the equipment at this age in faculty, physics. And now we have to do the same with the gravity waves, and it seems that it works. Okay. So principles of general relativity have been consolidated in the last 40 years. I think if we go to 27, it's much more. Okay, let's just give the tune for what is expecting you. And as I said to Martin, there will be a class with something to teach. So it will be a class. And I have difficulty to understand Aula without teaching something. Okay, it's now my time to return what the nice words that Rui said, because out of all the many people that I worked with, I want to single out the PhD students. I think I started early because I stayed here a few months and I was back to England I returned and I started with Anna and soon after with Antonio Fonseca. And there were many, not so many, but they were a nice group for the reasons that he was honest, pointing that I was really somehow sticking to these obligations, not obligations, the thing I like to do. Okay, Antonio Fonseca, I was a co-supervisor, co-orienter with João Batista. I guess that he must be seen somewhere. And around João, I must add other words. Why I started so well? Because João and Brooke took care of me. We were really the pioneer, first of the pioneer group sent to foreign countries to get the degrees. And João selected me. Okay, I only knew João in the interview, but João was putting attention to people from faculties, and I am here because of his decisions and of his friendship. Brooke, I met him recently, and I decided to make these postermissima classes. After we joined all together in London, in the University College of London, because Brooke made is 70 years old. In England, this is not a so visible formality, but we were, my colleagues and friends from America, German, Belgium, and so on and so forth. Some are ministers and others have been directors of many things, and it was really a pleasure to find my supervisor. It was, I guess, if not wrong, 10 years ago, 12 years ago. And he made his lecture. Okay. And I invited others to keep, as Paulo said, keep the tradition and strengthen it. So Antonio with João, Rui with myself, so he got more time and more headaches, I guess, and with myself and Assange, and then with the IST, with Luís Guerra Rosa, José Jorge Cruz Franz, which I did not see a long time ago, but I think he is online at these moments, on my friendship regards to him. Then Fernando Lencarte Silva from UTAD, okay, my eldest student, he is now retired. If he's online, it's a pleasure to have contact with you. And Florin, okay, always Florin, our Florin, okay. And, okay, then I start to have, okay, I still kept some co-supervisions, José Ramos Gomes in Minho. And then I start to profit of having trained these 6 fellows first, okay, because Rui helped me with Felipe, I think he's somewhere, okay, and Pedro Tavares, okay, I did it in chemistry, okay, I have a student that got his PhD in chemistry. I must say that I have only 2 subjects of chemistry in my university course, okay, but how many books of chemistry I've studied after that, I do not remember. Gaming Shah, okay, I helped Ipan with his thesis, and the thesis is in Chinese, but I have all the parts translated for reviewing, and the examination was there, I missed it. Okay, and José Frade, com Antonio Fonseca, okay, the benefit of educating some is that later others come and we have the possibility to spread. With Vitor, we moved to Aula, Farzi with João Amaral, and now I'm going mostly with André Salak, one of Advantech fellowships, Daniel there, okay. He has already submitted, and soon he'll be examined with Christopher Brett, and the last but not the least, João Cardoso. I'm just co-supervisor for André Salak, and Vladimir Schwarzman in Germany. On this set of my students, I give my thanks to all the students, all the degrees, even senior students if they exist, okay. And I will here and there eventually go back to some students. The title is a bit ambitious, but it is something that is very wide. So I expect you to have the patience to hear something on science for a little while. I'll try eventually to skip a few of these very elaborated transparency just to give notice how it followed. And why the encantement of knowledge? I think Rui summarized it. It starts when we are kids, and it ends by the time we forget who we are, or something like that, because it is a compulsion. Okay. It is, I think, a compulsion of our species, or of many of our species. Topology is a very simple discipline of mathematics. I think that we have it in our minds. Okay, that's why we can write. That's why you can acknowledge that this is a donkey and this is a man, or this is a donkey, a man, and a child. Really, kids represent in a very graphic way humans. Before the kids, these guys that have not a course on drawing, they did the same. And look, Leonardo da Vinci also thought about our geometry, our topological relations, okay, because of equilibrium and because of our conscience of beauty, after all, of what is beautiful. But it plays some tricks. Look, if we ask a computer, or if we follow the ideas of the kids, somebody without paying the due attention to the drawing will wrongly concluded, okay, this is not human. And if he had the feeling to biologists, look, this is a arachnid, okay, it's an arthropod, okay, eight limbs, it's an arthropod. Why that? In a while, I think 30 years ago, they were still PhD students, the automatic machine image recognition was relevant. We use it because of speleology, because of materials research. So I remember that quite often the algorithms have to compensate with mathematical reasoning, although these were very childish like computers, nothing similar to the ones that take our photography in the motorway, or the police that takes the speed under the photography and sends it all to us back in a few days ago. I'm going back to history because first, I was supposed to have followed humanities and not physics, but physics went. Second, there is a person in our culture that is misunderstanding at the present, I may say, poisoned by the 19th century and the 20th century, at least the first half of the 20th century. But when I was reviewing some of these books, I found that, after all, a professor nowadays has the same questions as this guy have in the 15th century, because he was born real by the end of the 14th century. And I forced myself, okay, to go back to Zurara. Did he really said so, or did the historian really write that? So, and the principle that he translates up, it was 1433, a disaster for his investments and for his projects, because Julians just came back empty hands, okay, and it was not the first time they say that for 12 years they were trying to go there. It's this, the myth of Adamastor, as it is already. But really, there is something that we do every day in research. We read everything. We read everything. Do we believe what we read? Hardly, because at the present time, we have to read many things, and the authors rarely coincide. And if they coincide, it's because this research is already done, so there is no reason to go around the Adamastor or whichever is it. But the second thing that I'm warning you is, sometimes it takes all a life. Okay, this is a map. This is the point of 1433. After all, boats shipped throughout, the Arabs shipped around it, but the myth on our minds, the myth on their minds was Arab, and we know, and it is documented. How did it progress? Okay, after he went around, he became famous for himself, I must say. Many professors, we are famous at least for ourselves. And he spread, okay, I know how to navigate. And you write to the Pope, and you write here and there. He made his papers on that. I know how to navigate. And they really know, because they return rapidly, going around from his lands. Not along the coast, but in the open sea, with the little equipments, but a lot of knowledge that they collected from the cartographers, mostly of Baleares Major. So, what was eventually the drive behind the religion, politics, economy, money that is spent? There were these maps from, just say, more or less the time he was born in 1394, but his maps were circulating in the courts and those that did investments. This myth is what represented in these early times. Prest João, okay, they say that it was a fake letter to the Pope, eventually it was. But if we could go around to Turkish are now there in Constantinople, this is all of them, not of us. If we can go around, and that map was really a very promising base for a project. How did it proceed? Okay, got there. He got some business 1444, but it is if you look to the time, then 46. Then there were Cabo Verde, not expected, but they were just able to navigate. So it was natural that quite often the results we obtain from research is not what we started with. It's just quite often the opposite. And they had that question in 1456, 6 years old. In these early times, it was not a really young man. He started sending guys to the Senegal River, okay, just a river. Go there, that was the mission here, 3 boats. One was from his own pocket, 2 from Monsieur Cadamost. I fixed the name, I remember that name from my early studies. And they went there, okay, 100 miles, just another river. Here they did not enter because these guys were not friendly. And finally, by the very end, they came here to Bissau and just another river. Okay. Why did I mount it? It's because really by 4060, the year he died, he could have noticed that after all there was a very wide ocean going to east. Okay, but as we all know from geography, that was not the case. And there were investments and many things for 60 years, so it's hardly that our promising science came in our lifetime. But it is the one. What was really the benefit of it? It was a completely change of policies around the Mediterranean and around Europe after all. So, this is just an introduction. Now I'm moving to science. Okay, my computer is a bit, okay, I will not spend time reformatting. This belongs to the next lecture. Okay. So now let me pay some tribute to some students, this of PhD, others of master, Antonio. I still have some of your drafts. Okay. And the time you work with it. Sintering started for me with a Richard book, and Sintering gave me a message by 1987 on policies in science. I was really, if I'm not wrong, in Kent, and I said, "Oh, Professor, how are now the studies in Sintering?" As some people that remember, you just say, "Michel, Thatcher does not pay any more studies of this kind at the present." Okay, so that's why I moved to Germany to work with Tatsov soon after that. So changing in policies may kill nice research. Here in Aveiro, we could afford to do more than that for at least 1 decade. But I must say that Paul is the only one I acknowledge that is still spending time with Sintering. Okay, but we need it to produce. This is what I tell sometimes. It's very early. All the Sintering into plots. After all, since 67, all what we have done somehow can be summarized that. But why that? Okay, it has kinetics. This is the general equation. We have activation, we have grain size, and we have the driving force. When you do that, and I did it with an external driving force, it is in my thesis and paper, sometimes we arrive to, okay, I have grain growth, but I do not need it. And I have the same kinetics, but I do not need this factor. Okay, and it was my key issue for the thesis. Why? Okay, this is creep, lines was 3 is plasticity, grain size is transparent for it, people doing metallurgy knows it, but we still have it. So I have to go around the question, what brings me logarithmic law for the kinetics? The question was very simple. Okay, there was possibility, forget about grain size, just think about any equation that puts an exponential of the variable on the right, so on the right, and it worked. Okay, so I was aware from that, from the mathematics in physics, and Manuel would have done eventually the same exercise, and then looking for a cause. And the cause came from publications. This is still the original paper, and the way I took the points to make this plot. Okay, well, the smell was obviously, this is an exponential, so that was exponential with it. This inspiration comes from heavy work, and I must quote here Lencarte Silva. I was quite enthusiastic with his findings in his thesis on nitridation of silica, And I was there in Villarreal, and I said, engineer, that's the name. It's still a lot of inspiration. And he said, correct me, not inspiration, 95 of transpiration. Okay, so that's the only condition in science for us to progress. And it was it. Why? Because this paper from Vieira, he did the calculation with all the balance of curvature. It's a set of 4 of. I have here one of his papers, but 2 of his papers, but there are more. And these calculations were possible with the Fortran codes of these times. And he solved it, and he showed, okay, these are my outputs, this is my transformation. And soon after that, we start talking about stress concentration factor. That was most of the work of Anne with Pedro, and others after that, but not so many. So, but I had a problem with this formula. I get a very nice straight line on something that it is this, somehow this angle of reentrancy here, but do I have this? Do I have these angles? I spent some time, that's where I learned transmission microscopy. I just wanted to see if these angles existed. Then it became my habit, and I tried to find some of these equipments to this house and was using them otherwise. Why did I put here this mark? A comment to Rui, okay, I have to pay back. Last year, 2021, he approached me if I was available to teach a new course. I remember I might have said that, okay, but what is the course? It was from Symmetry, Vieira. What is the subject? And I said, but remember, eventually you are inviting me to prepare the 35th new curricular unit in my career for the Zurich University. But I thank you for that. I learned some things, used most to work there with Daniel and others, and I also learned that I could have saved myself months of mathematics, because really what I did have been done early before for surface science. It is called the Delovich equation. After all, I have here my equation wrapped in a matter of adsorption, and I have here my kinetics wrapped in an equation of efficiency of adsorption on the physics surface. Okay. Whenever the rate of adsorption is dependent of the amount of sites that I've been taking out. It is really not far from the pseudo-second order, better known, and then I looked for, and the paper was fully integrated in a publication which I think is that one here, 62. So I published my paper in 84. I could have saved myself 12 years of mathematics, which I did by end, and trying I convinced my supervisor and somebody in the States. So research is that. Okay, this is then writing of Richard Brook when he convinced me that, okay, logarithmic log comes from here, but eventually we may find something else. We were already somewhere in half of the research, and that was for me to consolidate. And this is where we can express most of the course results on copper as an exponential of grain size and exponential of density, and bringing it back to the densification rate equation. Okay. Support for research, I did already comment. My intention was to remember that Thatcher stopped sintering studies there in UK. Now the papers that I quoted and the drawbacks of these findings that still exist for those that want to investigate and review and reinvent the kind of things. Okay, this is from Artesis. This is from the paper of Anne Mantas y Senos, 2005. We really can express the kinetics as an exponential of the porosity, which goes, and by the end we ended with this function that it is a compensated function that translates the effect of porosity on the rate. Then the A's that we see here of the equation, which I should have written, are not completely out of expectation. The A's and the N's are not completely out of expectation. The diffusion coefficients are also fitting known values for the zinc oxide, including the depth. But when we overview widely that question, that's still an open question after all, there are many examples of, okay, it did not come out nicely. Okay. There are many examples that are completely out of the range that we can explain with the pore around the grain boundary with all these fluctuations of shape, and we can easily see why in the next transparency. We cannot find a pore on any corner or a pore around it. There is another topological relation hidden that these models will never account. That gave origin to second use of topology, and I said that the summer that I will talk about topology, which introduces us in the work of others, Germans, but here in Portugal, Manuel Amaral Fontes and Alberto Ferro. This is from the Hof. After all, if we want to get rid about a very regular tetrachide polyhedron, or tetrachedecahedron, or do we have to choose next? Okay, some more abstract mathematics, and the paper is really a bit heavy. Okay, but if we can represent everything within a mathematical cell that has acceptable geometry and translates to what we see here, okay, I can draw it inside one cell instead of keeping the whole particle. I think we can get rid about simple geometric constrained forms. Second, this research has been going on even 96 they are still evaluating and proposing new formulas. Shen is still making hot pressing exercise there in China, but progress was not so easy. So what was the achievement and why we went back? It's not published, and it may well be published after a few more months of reviewing. It was that if we go to a more abstract algebra about solids, the tissues, the cells, the metals, if we unglued all these things, have all the sizes from tetrahedron up to 20-something faces, 30-something faces for large size. And they were able really to review the trivalent polyhedron. Trivalent is because all edges meet in a corner for a particle itself. They give good accounting of 3 ways of representing the solids for us to make some counting, and one is the standard shell diagram. Okay, I will not spend time, but I try to make the same tetrachedecahedron into one of these, or to make the graph that may represent this is the largest. This is not the largest face, this is the largest amount of nodes permitted by this figure. And then with the complete graph, we can see that after all the faces that we have there and their relation, squares and hexagonals are here. Why that? Because it is a complex story. There are enantiomorphic forms, as in crystallography. There are, as we increase the number of faces of the polyhedron, the number of possible different polyhedron, after all, increase in a very rapid and sharp way. So we could really work with this as a closer approach for the real materials, as models, and as I said, as models. They demonstrate with solid mathematics that for these structures, we can talk about an average number of faces, which is a real, and an average number of edges of the face, which is a real. Our invention was to go back to the Hof. Go back to the Hof and think, okay, if everything is average, density is an average property. Let's try to go to the density through this construction. It's a student's mathematics. There is a solid angle that projects from here to the unitary sphere, this same solid, and we have height, side that have to conform to the topology that we have just reviewed. What was the surprise was not the solution, because as George knows very well, we may easily integrate an equation if we have a numeric method that converges. And this is the equation that translates that the solid angle and the solid given by the parameters of the model, including the n and the z, has to be 0. Let's say the two values have to come to convergence. And it was done like that. Early, it is not published, but I put back 1997 when we first submitted it, and then it was left aside. What was the question? The challenge, I was not happy. Nobody is happy with having a numerical method. Are we, George? I do not think so. So I looked to the question. It's so elegant. It's so smooth. No discontinuity. It might have an analytical solution. But my geometry, my Pythagoras theorem, it was not enough at all. Okay. And the book of equations that I have there from Schaumann or something. No. So I learned, okay, let's go to artificial intelligence. That was my only case of artificial intelligence of success. But to learn all these new practices, programming, it's very nice, math hard. Okay, now I am short of funds to update the software. But look, 4 roots for that equation. The real root that has physical meaning still has a good doing. Okay. But it is analytical correct. If we inject the solution into the equation, it really zeros the equation, and it then can be worked with the previous relations that I have there to give me density coordination number relations, which I was looking for to make the topology and going back to kinetics. Okay, it will be done in the future. I just have now a second stupid output. And research is full of non-results. You see that I've done numeric by 97, and I did mathcad by 2014. I remember because of the license number. Can you distinguish the difference? No, the difference is on the 4th decimal, because I imposed a very good convergence. But it gave me readability. Okay, we can really now know that to the question, it is mathematically sound and solved. The model itself is a red line. Other equations earlier than that. After all research could have done with any of these equations. Okay, the actual equation is not it translates into an inversion. Okay, 1 upon p, as we see from the shape here. Porosity goes to 1 upon p. Porosity goes to the left. A case study which brings many nights with a very childish output, but a lot. People likes to do crosswords. This is because it's a really curiosity. Okay, it was. I got all the feeling that by the end, the numerical method for engineering was more than enough. I think I'm still on time. We do not have a Bodel, okay. Now I have to make it much shorter, okay, because that was easy. And now, yes. This is also a moment to remember, a moment also to review and even criticize things all ourselves. I'm heavily using here 10 years of research from a nice guy that is now in Zurich, and others, but okay, and Mark Willinger that was recently here, and I try to package it. For those that want to pay attention, and young students may eventually be examined in the future in the aggregation around these matters, that's where really came the major titles, simultaneous symmetry breaking. And because the model we use in materials was really imported from 76, from model prepared for cosmological needs, I will try to jump some of my findings and go to the analogy. Really, it was from one of these programs that started and have no continuation, our collaboration with Middle East countries through the Sesam project. Marian Gago himself was engaged personally in finding universities for a set of students from the Middle East. My old friend Gaspar Barreira, he was a colleague of me in physics. He did the management for Marian, and Sesam exists and is working in Jordan, where they have a synchrotron facility. Okay, I supervised with Victor Wali that came from Tehran and worked there, and he was pleased because in the last presidential elections they have here an election bank and they participate in the political activities of their countries from the University of Vieira, and they were also somehow the expectations of Zamarian fruitful here through these guys. Okay, and now they are somewhere. What is here the question is, university class of symmetry exists, but for us to see these things in the real world, in that case, we really have to go to the best of the equipments we have to see in the very small. We have a rule that all the world was in between 20 to the minus 12 and 20 to the 12. I think this 20 to the 12 now is very multiplied, okay? But I remember it from early classes there in faculty. And these are two of the equipments that now allow us to go to the two directions. The filter sense corrector IRM, because this is one that was used in this research, or the Titan that is there in ENL, the closest we have here, several in Spain, and here the Planck Space Telescope that is now forming the cold dark matter under the microwave background radiation and other many phenomena of special, let's say, of planetary and intergalactic research. What I will try to do in a short in this part is presenting the phase, showing the observations of Coulomb and Higgs phase. Higgs is the suspicion name, trying to explain what is this symmetry breaking, the relation of this with theory, using very simple rules that hold for all solutions to present how we go around some of the difficulties in the laboratory. The systems we chose were very expensive because lutetium is one of the most expensive rare earths. I still remember 5 grams, 2,000 euros, that took somewhere from the project. What we did the research with lutetium because it has the highest Neal temperature, okay, which is here in this column. The transitions of phase that are relevant in these materials is from polar, non-polar, highly symmetric to the polar ferroelectric, and then to the antiferroelectric, keeping the ferroelectricity. That's why they are of interest. They are multiferroids, but at 90 kelvins, there is not much more to be gained from the magnetics. Sorry, I got lost. The trimerization is really a superlattice, but can be described as a superlattice of the highly symmetric phase. We can see on the left how the atoms are moving. Really, we have some magnesium is not changing much. The rare earth is moving, and oxygen is now there is a polar oxygen that also moves. We may say that the superlattice has a much wider lattice sides, but for plasticity, as I will have, we can always express dislocations as true dislocations, not partial dislocations of that lattice. Okay. What is trimerization? Why it fits to the theory is, if there is no long-range correlation, it may happen here, it may happen there. Once it happens, there is a very rapid transmission of this information to the next cell. Speed of sound is the reference, okay? And it may be reversed later, but if temperature is high, or it may just freeze in. That's the concept. So I have at least 3 networks starting in space at different origins, A, B, and C. Later on, the magnetics, this is just a little twitch that created frustrated magnetism. And the frustrated magnetism is important for the magnetic or the electric or the magnetic elastic couplings, which are scientific and technological properties. If you do allow me to jump on the physics, that was the best we were obtaining by 2017, 2016. The microscope that sits next door can do these perfect images in filtered energy mode. But this is transmission, it's not STEM. what we really need was STEM, because STEM, we do not have the coherent interference of all the planes. We have really, let's say, not a mass weighted, but mostly atomic number weighted image. Our STEM, which later came into operation, allow us to see that we have the polarizations of the models. But our TEM was not, we are not happy with it. Okay, anyway, Ali was already publishing with me and Mark and others these outputs. So we were able to see, okay, this is our lattice. Here and there we could see effects in the TEM image of the polarity, but what happened to the effects of the crystals. We are working not with zinc crystals, but with ceramics, which puts grain size, impurity, strain constraints on the samples. And our frustration, not of humanities, but our frustration in research was, okay, this is what was published very early, 2001, but we can only get these things, okay, these eventual are these vortices, these topological vortices, but okay, are they the best we could do? Marta has been following us in that. Okay, here we have the trimerization, okay, this is a positive trimerization, this is the manganese planes, perfect. We have the equipment there to see that, but not nice pictures. Okay, just a very rapid overview on topology. This is how, in a single case, you can see all these domains, all the vortices. This was Paul, so the positive domains are expanded, the others, but the vertices do not move. This is a topological representation, the dual graph, where every point represents one of these vertices, and 6 colors, okay, because there are 6. And this is the counting done by, remember me, Xue, to demonstrate that, okay, the topology was there, it was 6-fold, or we may say Z2, Z3 symmetry. The project was already started when 2 key publications appeared. Griffith, 2012, we started 2010. Lin, we are already starting about thinking of thesis, and these papers are now the most important pieces for understanding of what was going on. The spontaneous symmetry breaking with vortex lines, okay, it all started in superconductivity, then it was same time in liquid crystals, pneumatic liquid crystals. Papers on superfluidity of helium are also from the 70s. More recent in non-equilibrium convection, Bose-Einstein condensation, quantum computation with King pairs in Ising chains. These are all the related fields where the papers merge together and complement the theory, and others. It does not intend to be an exhaustive review. What is symmetry breaking? Okay, at high temperature, at high temperature I have an apolar phase which is highly symmetric. Then I cool it down, okay, it has to decide, it has to take one of the trimerizations. By the end, all materials, all neighbors will take in sequence, we will see in sequence all the possible events, but this is a lattice. It's different. It will be in the Big Bang model, okay, the standard equations of the Big Bang model. Really, what we observe are the cuttings of these apolar phase cores in a rather well-defined and well-crystallized polar phase. What we see are these 6-fold symmetries, 3 positive, 3 negative, with the trimerization split. In that case, the ferroelectric and antiphase boundary coincide, the 2 energetics. Okay. What is this mathematics? Okay, it's not for any student here. Paper is published, okay. But how does it read? We have really freezing in of the structure as it cools down. We have causality as when one switches, the other one next has to switch, so we have a correlation length, and this is one of the fundamental concepts in this physics, okay. Secondly, we have a characteristic time, which is the relaxation time. They can go in just related by exponents, and after all, the zero temperature, tau zero and x zero are just related by the effective speed of the causality. Manipulating it, cooling rate is just somehow a clock. If it passes the critical point, it stops. Okay. And by manipulating it, we really get a nice equation for the density of the topological defects, the lines. What was our question? Where was the test? Okay. Papers were mostly on yttrium. And the exponent was public and well suited for these materials. How does it cross with the fundamental models? Okay, really all the solutions for us and for the people doing cosmology started from the concept of Lagrange multipliers, the Lagrange as the minimum action theorem from the rational mechanics, and simple plastic has two terms. This is kinetic energy, this is mass. If I'm in a potential can be seen as a virtual mass of the field. Okay. And there is a situation in the theory of black holes where this virtual mass seems to really exist, and many others where physics has proved. If I have the gauge field, the Lagrangian has this phi to the 4 power, and what is now is that the value of the field at 0, this is order parameter, is finite. Okay, if we go to the cosmic model, okay, as published by Q, we found here the key issue that makes all this symmetry breaking similar, and this is for the ferroelectricity, the transition from a polar in a hexagonal magnetite. Okay, Q here is the vector of the K3 distortion. They look nice. Mexicans here win the point because it's quote Mexican at everywhere, but it is just a question of these two terms in mathematics. This is Excel calculation, and this is where we say, okay, I have now a symmetry U1, which means a line of symmetry, meaning so that phases can rotate, but the K3 node is already decreasing from the 0. The value of the fully symmetrical phase. So fully symmetric, symmetry breaking through the Laplacian equations and the free energy that we derive from that. Photographies are really what makes materials nice. Am I right there? I will return, remember before I pack all my things, I will return that nice sample from Tony Wilson to you, okay? You are entitled to keep it. And our results were a bit disappointing because to come to here, okay, we have very nice piezoferroelectric sensor force microscopes in CSEC, yes, and that part was done mostly here in Alva. We have STEM, okay, and when they perform, we can guess. But this is the images published by other groups that teach us many things. So my first part, as a supervisor, what makes supervision difficult is the same as that guy Henry has in the 15th century, where really Africa turns left. Okay. Because results were many. There was a first, by 2001, there were some results on these temperatures, but looked for to lutetium was really a matter of reviewing and reviewing. But at the same time, Scandio proved, okay, it will be above melting point, so there is no use to be looking for controlling the density of the effects for Scandio. And the ferrates are sisters of the manganites. They also have the same transitions, and because somebody published in between, I did not put the for reference, I may tell you, they did not put in between here where they are, we can more or less confirm that these are points of the same effect of lattice on Curie point. Really, the paper of Abrams fundaments that because somehow dzi is a function of the Curie point. As Curie points and Neal points are correlated, these are materials that are not exact. This is a mixed manganite, can be either hexagonal or perovskite like. We got the impression, okay, it's all the same cause, and the cause is the bending of the B pyramids inside the lines. Okay, where were we stuck? Nice images available. PFM. Okay, not super, I've not been there myself, but stripes. Where were these vortices expected from the X phase? This is named Coulomb phase. And even that, I must confess, Ali did a lot of effort to put this surface. This is ceramics. We know that this is ceramics. These are the grain boundaries. They stop. All these films stop at grain boundaries. Okay. And this is a published picture of where we have the six-fold and the four-fold topology. Four-fold topology has been explained as an interference of these locations with the topological class of the manganites. Somebody asked me to speak loudly, but voice is a bit weakening. Okay, TEM was not happy. STEM, now from Berlin, was much better. We started doing our looking for defects, and because ceramics have always many defects in their structure, we could spend a good time characterizing them. This is one of the recent pictures. This is STEM. Okay, the six-fold. This is a courtesy of Ali. He sent it from the Zurich ATH. And as you see, still nowadays, it's better to follow the six-fold geometry with PFM or other techniques. But in ceramics, things are very small, so we need a good microscope. And this is after he uses FIB, one of these surface crowded in another scale, crowded with the topological defects. Next, is there a message? When we already know how to see changes. We reviewed, and that's what I present, how the density of the effect changed with the changing the solid solution up and down. It was really visible, collecting the data 3 years ago, that this is Itria, okay, I should have put it here. This is the last one, is first results from, our results from Lutecio, that there is a regularity of the laws. This is the KZM that brings the kinetics as given in the equations before. Okay, not nice, but enough to answer one additional question. Are they correlated? Okay, this is already forcing the model. The lines represent the ranges. This is one of our last publications from 2019. We get points enough to know Lutecio is here, but research never ends. So be aware, research never ends. When we cut, as it is in a previous transparency, so I'm trying to remember where, okay. When you cut these lines, or opposite, we could cut in the vertical, we can work the equations of the Kibble-Zorek model, and then asking ourselves what happens to the physical constants, the concept of causality, the correlation length, the correlation time, what is the scaling of these variables. At the same time, I must point it that the black line was purely empirical, and I use it, that's why I'm a bit tired today. I use these last months to review everything, okay, and tell you what we may know, what we may be right and what we may be wrong. But I was surprised myself. Okay, this red line exists. Okay, it was in the paper, in the very early paper, 2012. The guy said that it might have a slope of 0.27, which is the characteristic slope of the KZM model. And I looked to the question, it seems to be true. Okay. But all the mathematics has to be rewritten. So, what surprises that expressing it as length. That length should be here around 1 angstrom. Models have been done, equations have been written, but when you take and we fix it for a constant velocity, these values of the cuts, we come to a very changing variable, 2 orders of magnitude. No way to putting it in the speed of sound or in the speed of the pack of waves of sound in a crystal at these temperatures, because we are just moving from 1100 to 1500 centigrades in these energies. It's too little for that. Really, we got an activation energy that is typically high for the parameter if we express it as in the Arrhenius plot. Don't ask me why. The second, which was perceived, is if I do a double logarithmization, okay, this is already the logarithm, this is still the logarithm, but now let's force another logarithmization of the scale, a straight line appears. Okay. We know where these double logarithmizations occur, Weibull related statistics, which is Poisson related statistic, which is sometimes also the Gaussian distribution item. These three distributions can be compared. Okay, did it go further? Okay, the only thing is we can really work. Okay, here should be lumped. Okay, but the PowerPoint has mistyped it. We should think that there is here really the randomness. But the full statistic is not developed. That's the concept. But this is really very fresh results. So mathematics and physics and materials and cosmic phenomena all come from the same barn. Okay. The other question is, okay, we have here a lot of information on the Newton temperature. The concept of the Vegard's laws most or less tells me that there should be a wide range of solid solutions behaving well, and there is not much more to be said that this is a lot of publications from 2 decades. What emerged is, okay, I have to acknowledge that this author, which is Dissler 2015, made a nice simplification of how Newton temperature, how antiferromagnetic order depends on this solution, but it did not fit exactly the needs. Here we have a very nice definition in the laboratory. Here we have a very nice definition, and these points are these are represented by good experimental results. There are also studies of solid solution along this line. There have been now studies of solid solution there. This started from a claim that there was really nil materials of this class with nil temperature around 400 K. It would have been a jump. Nature does not like jumps. Okay, there are discontinuities. So what next? We really did our research. Only took 3 years of postdoctoral, not just for that. Ali was able to show recently, here is the publication, 2021, that the films of this solid solution, which is scandium iron, really have, in given conditions, temperature is very close to the expected line. Here the substrate was changed, and the film has lower properties and is deviating in a visible way from the 2010 line. But why do we need this? Because these are the golden rules. Now, the interplay of these locations, topological defects and other geometric defects. People nowadays, they say that everything is topological. Okay, I'm not so expert on the term. Okay, since 1980 something, okay, Pedro may remember if I was his professor for mechanics, I'm not sure, no, I was not a professor for mechanics, but youngest. Plasticity, the Frank Reed, the dislocation, the Burger vector, and so on. Are these locations topological defects? Screw dislocations in the continuum may be said yes. Okay. But they serve as a simple exercise. As a topology class, it has very few features. When they cross the Burger vectors sum to 0, we may have closed loops. Okay, A minus A. The networks are trivalent polypolyhedral, as said before. But for my interest is a different thing. We, in ceramics, we have really this as a problem since 2014, first STEM result. This dislocation just moves the phase one unity in that space of phases. This is a very nice picture from Cheng, and microscopes nowadays are used to the limits. We can go around the STEM image at the resolution of 0.7 angstroms more or less, and trimmer and see how much atoms have statistical shift here and there and where they have shift. So these locations that existed here and change the number of phases are easy detectable with, if we get an image of this quality, a sample of this quality, a thin section of this regularity. And why to bring it up? Because we have been investigating also these dislocations for technological reasons. We found a very strange dislocation. Can you see how this dislocation, this is a stacking fault created by partial and dislocation. The atoms are more or less looking face to face, face to face. The lattice does not have this feature lattice. They should be up or down. Very recently, even as I was reading it, I said, this is our dislocation. Because he published this model. If we move that one to there, we will put blues in front of yellows. This is a carrying exercise just to be sure that the blues are in phase with yellows. Face to face here, face to face here. And the translation vector is in the 4 index notation is written there. Little jump to C and one phase shift in the hexagonal plane. One of the effects is that we may have many countings, a 6 or a Z2 false, because here there is a dislocation. Why really the phase shift from the high symmetry to the low symmetry is just a vector equal to the dislocation shift. So translation and nucleation interfere. This is just a summation to explain it by other words, and this is highly controlled sum because we put ourselves above the phase transition temperature and we give a controlled quench rate which is in 40 Kelvin. With all this engineering, the reactions of spontaneous symmetry, breaking in materials appeared and followed and talked to us. The image I have on the right is now out. This is a regular phase, 6-fold. 1, 2, 3, 4, 5, 6 on the black. Borrowed from Manfred Fiebig from the same Zurich Institute. This is the visualization if we put one dislocation loop, or if we put 2 dislocation loops. We start with blue, we end in another phase. That's why we do not see the 6-fold. We start counting 4, and by the end even just a loop, an additional arm in a set of 6, which is a bit difficult. It was for a while a bit puzzling. Professor, Sr. Doutor, mais 5 minutos. Não está cá a Maria Helena que se riu há dias, quando ele disse que já me tinha acontecido a mesma lição. É que eu aqui sei que já passei no exame, Eu só vos peço paciência. I call this epilogue. So it means that I'm coming to the end with my lecture. Here there is no scientific novelty. It's just a bit going back to the poetry of research. And also talking about some things that nowadays may be puzzling our minds after centuries, at least after 5 centuries of general acceptance that research and science are really essential, not relevant, essential. So I will go now to the outer space, but I want to make here a very, which is also a tribute to this university, but I do it, the tribute to Aristides in a very personal way. And why personal way? At the time when we were there, Aristides was one of the vice rectors. I think he was vice rector for this building. I remember because we have been reviewing the room to put the microscope, our ways to do the things. And because he was also a key person in chemistry, in the foundation of the university, like João and others. And you that are here, and everybody is important, but those that arrive first to the landscape, they are essentials. And what you are seeing is a tribute of nature to himself, to Aristides. Why? Next step. This is when a new kind of tourist migrated to our town. It's Praça do Peixe. I cannot count them. Young fish, not babies, young fish. Okay. I'm not biologist, but it was the full channel. Okay. Full channel. And they said, why these fish came here? First, because they did not die. In 1984, they will have died before entering the Barra. Okay. And why it is important? Because Aristide in many ways proved that science has an obligation, which is public awareness. And he is really the author of this key paper, which I knew that exists, but I have not had my opportunity to look for. The publications is 87, and where he said something is very wrong with the waters of Aveiro region. And when he said so, he said, these are big guys, these are not the small guys. And he had a very public conscience of that. There were several publications after this one. He named the places, he named the councils. The content of mercury was 10 times or 20 times above. Now the fish know that Aristide all existed. University has paid this tribute with the pavilion, but it is really what I said, a tribute to public awareness of scientists, because we have a huge responsibility. We know the things. We have the responsibility of knowing. So, what next? I think most have been said, and without formalities. Okay, I can see here Renato that found me interesting enough to be in his team. We have spent 10 years. I was taking papers out of my office, and I said, okay, it was more or less 10 years discussing this university inside these assemblies and councils of the university, and besides many other situations, including the council. And after Renato, Julio might have, I think Julio is hearing me, my compliments also, I talked with him recently, found that I would be still of some use, okay, and I did my best. After Julio, I think it was Isabel, okay, and after Isabel, Elaine, I was in the other part, okay, we were three, okay, Joaquim, okay, Vite entrar, Chico Vaz, já falámos. We did our best. It was a time of changing. Eventually, I also might have changed. But after Elaine, Manuel still found me some use in things of higher responsibility. And I must acknowledge that Paul did not forget me, just for a little thing. And we all know how important it is that the community keep doors open, bridges in between academicians, and eventually even rethink it's our way of doing that. Statutory, I mean. Universities are schools, schools are colleges, colleges are highly linked people. Okay, anyone in its own tune, But it is a pleasure, really. And by 2008 to 2016, I made my examination conscience, and I decided 24 years, it is almost enough. Okay, so I slowed down, and it was conscientious. By that time, we are all engaged in a very nice project. I have never been completely honest with most not, but not. I forgot to put in my CV that for more than 1 year I was the student, one of the two students in the Council of Faculdade Ciências, and I was writing the CV for FCT. Okay, I'm forgetting. It may be irrelevant. Okay, I was coming to retirement, so eventually it is of little relevance. But it was some kind of training that. Tirocínio, that no one knows why I was there. I only discovered after I was elected, I think so, something like that. Anyway, universities are, governance are very complex institutions. Council took me some time, several councils. I gave my best, and I expect that those of today and the future can do even better. Then, okay, João is here. João Tinho está, o Luís Carlos não vi entrar, talvez não, maybe is online. And for me, institutes mean many things, but also means CISECO. Okay, and must means CISECO. Okay, they have the patience to keep me up to the last day. I must say that after some moment, I cannot tell, I was more engaged in my equations than in CISEC. But there are a good number of people to do the other things. And there are these courses, the PhD in that thing and the PhD in other thing, and all the bureaucracy that course management every day in an increasing way. I think rectors may rethink a bit of how to manage a PhD course. I've always said PhD is not the first degree, okay, but this message seems harder to pass. We have here the nucleus of third cycle, but it's still very high, okay, and Roy knows what I mean. And John Abrish, I've seen you. Okay. They know on their own day-to-day all the time. Okay, institute governance, I do not say much more on governance. Okay, do I agree with the president? I see some really constraints, but that would be another talking. Knowledge creation and simulation, I'll come by the end and I will close my lecture. Okay, talking about outer space, I'm pretty sure that any intelligent species will not confuse us with this drawing of Da Vinci. They took care not to put the image there. So our topology will be properly represented in the future. We will not belong to the arthropod class. It should be changed. No? Yeah. I'm going back. I lost it. Okay. So now using something from others to be schematic on trying to answer simple questions. Is everything fine with scientific activity? I must distinguish science from knowledge. Really, I'm blending here a bit of things that are not necessarily scientific. And eventually in management I have no science at all, I just have some knowledge. Okay. It points several very important questions that characterize the moment when we think about activity and how much it test charge, really test charge from my times of faculty. I remember Cesar Viana, Bragança Gil, these first pioneering groups trying to do the best in Portugal as they did there in other countries. First, the volume of science is huge, exponential. We can no longer embrace no person, neither is no person like Newton or these philosophers of the 18th century that can say, I know everything about nature and philosophy of nature. We still have the philosophical magazines, but these titles are really hard. And the author says we can no longer embrace all the knowledge. It has accelerated too fast, so simulation is shortened. Theories are changing. I showed you 3 things that need no further theory. Okay. And these are just plain and simple materials. Think about biology, about life, about virus, or about space. Only scientific experts may eventually understand most and deep theories, but only in their own way. What is the difference compared to the TV, to the public, to the contact? Because we have now millions of experts in any country. Okay, are they? But they look like. And we also in the conference often we found experts of everything. Steve warns us that honestly speaking, it's very difficult and then think only very narrowish. I may know something about my material, but I'm not expecting you to follow my questions of today, honestly. But give me something to talk and I choose these things to talk with you. Second and next but not least, when we finish university, we are already outdated. First, because the theories do not come rapid to the teaching. Second, because in the 5 years of time, many things change. And this is real. Okay, what else? Only some can really develop deeper knowledge, but they have to pay very, that's why I call the disease of knowledge at the expense of a full life. And sometimes we forget faster than we learn. Okay. The remaining population, that's one of the roots of the problem. We are very happy together, here inside the faculty, inside the schools, inside the community. But does it has any reflex really? They do not participate in our inventions. Easily they participate in a successful football match. Okay, but not the matching of 2 professors discussing any theory or any laboratory result. They do not participate. Okay, and Stephen also warns us. He has published a good number of texts and conferences because he feels, and Zemari and Gago had the same feeling, and he warned us in the associated laboratories. Pay attention. You may fall in a corner if you don't pay attention to how public reacts to what you are doing. And scientists, that's more philosophical or ontological, rarely put the final question, why? Why do we have this loss? Why do we have this universe after all? This is purely and deep. Okay. How much has science expanded? 2009, these maps exist. Okay, they are more detailed. I put it here because this could have been more or less a transmission image of an amorphous material in STEM. Okay. Where is the island that has governed my activity and yours? Okay, Syssaco. The materials engineering, almost in the antipodes of chemical engineering, surprisingly, which seems closer to biochemistry and pharmacology than to the needs of a material engineer. I do not know if we agree with that. The physics in between is indeed vital. Okay. These maps have a mess. And here the scientific, let's say not the scientific, the more consolidated organic and analytical chemist. Syssaco, João, we really start from interdisciplinarity, right? From growing, 250 researchers, it's a nice number. But this map also has some message that can be positive or negative, okay? And one may be the talking of deaf people, okay? I use one document from UNESCO that also has another message, why things are changing so rapidly and why the reactions of the community scientific community are changing so rapidly. Look, 23% is a very nice business, 3% a year. That's a rise of employed people in science, all countries together. Definitely the developed countries have a good large share, but there are others, including countries in between. Eventually, we have nowadays 10 million guys like ourselves and others on the planet. Science is no longer a business for elites. It's a business. It's a need. We do not have better tools than to work like Aula said, think about, observe, test, make your laws, publish your laws, review your laws, and go on and on and on. But it is a paid job, and if you are a paid job, your psychological relation with the object may change basically from the romantic message, And because it is really like that, this is from the same document, there are some things that puzzle us, and those that have to pay attention to governance and innovation, we are crossing these barriers every day. Science is a public good, okay, fine. But mankind makes good of it for peace and for war. It's public. We produce, but it goes public. Okay. Science is under tight control of governmental agencies because it's a good. It's a public and it's a good. And we can see that it may have reflex quite often in the program of institutes, in the program of your personal life. Remember how many projects were drop off from 4 years ago to the present time in our own area. And I know that by 2000, Bill Clinton and the Americans gave priority to other things, but not to materials or engineering. And we can find it reviewing the history of the priorities. Second, science is universal. Okay. We have thousands of papers available, thousands of reports, thousands of... There are strategical science, I guess so, but the science, the knowledge circulates. It's impossible to keep it in the Dropbox. Nowadays, we are paying attention to that. And the report says there is a digital disruption, big data, cloud computing, supercomputing, and in the bedside, bots and spiders. So when you read something, we may be reading the wrong report, the wrong publication, the wrong result, because events can be just invented and put in circulation. And the periodicals have a problem, the core of revision, the pushing for publication. To review my own paper, I may need 3 months. To review somebody else's paper, I may need more than 3 months. But they are accept or reject. Okay. On the overall, there is a good intersection line that proves technology is improving. Second, what we have is forecast. Okay. Data forecast is essential for diffusion. That is essential for decision making anyway. It is also essential to verify back. Okay, many publications we talk more about. It can be, it can may, but nobody tries or rarely proves this hypothesis in a more sound way. Science forecast. Real world forecast should be kept away from cybernetic, and I leave the reference for where this term comes from in fiction. And then knowledge and science. Okay, I put the question of knowledge. My culture, before I joined physics, or I joined at this high school, there was little science, but there was a large amount of knowledge. That creates nowadays a confusion in many situations. Because it's very novel to understand local and individual inclusion systems, yes, but quite often general public reads the message on the contrary. Anything that comes from these minority members of society have much more knowledge than science, than scientists, which is reading the message on the opposite way. Okay, if I've used them, now I have to navigate rapidly because I want to speak about space. Here there are two interferometers. They have been presented. Is science at risk today? And how does it link? Science is somehow at risk because Heisenberg said there is nothing sure. There is always, if you go to the very small, definitely there is this Planck area where we have a Planck length of 10 to the minus 25, a Planck density of 96, a Planck temperature of 10 to the 32 kelvins. And one philosopher said, at these temperatures, time and temperature lose any meaning. I said, okay, so if time does not exist, it's eternity. I think it may stay in Planck there forever, never materialize itself. But this is really one of the fundamental understandings to start the standard model of cosmology. A real standard model of cosmology is as old or even elder, something disappeared, as the observation of that faraway stars, galaxies were moving fast. It took me some time to understand why, but now I know. It's like if I put a piece of steel in the furnace, atoms that are closer have exactly the same expansion rate as ones that are faster. But if I measure it from my side, those that are faster have a large length and have a large dr for me to measure. So constant expansion means the Joule law. But very recently, it was on the 12th of April, Carl Schulreich, the paper is not for me, was discussing why it is so important that the mass of the W, or this is the, boson W, is not 8379, because if it is 8435, it means that what we think about his nature is wrong, because all the other constants of physics that go into these calculations are very precise. Okay, I have to skip, and I have only one question. Where did Alter put his model? Kimball put his model here in the transition from highly symmetric mixing of electrons, radiation, and positrons, and this, the energy state, they are all in they are all confused, the essential, they are not distinguished. Then they separate, okay, this is the table that gives this physics of particles, and then I do symmetry and I have the strings. What strings are these? We do not know. And this same image can be explained even by quantum gravity, which is not yet consolidated by other sources. But it is really that the distribution of mass in the universe, including the new ether, the dark mass. I'm not yet convinced myself that the dark mass, like in the past with the speed of light, which other theories really embodied it. But with the present interpretation, is not uniformly distributed. The new telescopes are looking for how segregated it is. but this is the closest image for these things. Why are they important? If the matter separate in our university, we have this kind of kinetics. Does it run? Okay. As usual, always happens when you go to a conference, things never run. Okay. 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 This is the model with the free energy for the crystals we have. Okay. It's sitting up. We can see a temperature. It fits full randomness. Okay. We need randomness because if there is no Lagrange force, things are stochastic. And because now it's cooling down back, it's the causality is enlarging. This is the length I refer, and in a sixfold we will have sixfold symmetry is now falling to the sixfold symmetry of the model. If we run it several times, we will see some of what may have happened in the electroweak phase transition. Okay. One of the consequences, cosmologically speaking, is that we are here, that our galaxy has a ring volume where life, at least based on carbon, hydrogen, and other heavy metals, is possible. We are not near too close to the edge, near too close to the dark hole that may exist there, and I think time has many zeros. Okay, our galaxy is constrained really to fall, and the Andromeda, or the opposite Andromeda may fall on us. But these are facts from the new observation of space. Two spiral galaxies are collapsing. We have one coming very fast to us, millions of years. But what is the public perception of science when the messages are like that? Really, the Greeks have a bad practice. Did I went too fast? I got lost. I may have stopped it. They used to kill the messengers with bad news. I think that we have not changed too much since Greek times. And when science brings bad news, we must be aware. I just selected that one. There are many other things that now we know that may happen, and our species is just a species in one of the nice planets, and we may. I'm going back. Sorry. Now I'm really tired. My students remember that. So the meeting. My philosophy on the questions that cause science, philosophy, and society, I got from the same authors because I was reviewing them. I really want to understand what this cable model, what is best to do, where this phenomena is modeled, and see. But I took, because it was the same way. There are important things of today. This is for the student, for the kids, not for grown people. The paper is from Calari Vales, and it is one of the last publications of Stephen and Lucy Joaquim, and I got end of it. I just summarize it. The merit of a project, after all, is a balance of probability versus cost success, small or large. So, can we be certain that outcomes of our project are used for the good or for the opposite? Hardly. But it puts a problem on our own decisions, after all. Because of good intentions estão inferno cheio, and many people know this. We produce knowledge without being aware. This is Google translation, but I think it serves the purpose. The idea is from the author, but I give it a touch, that's why I put it in brain. Adequate testing is mandatory. Our institutes hardly go to that detail because there is first cycle of life, cycle of life has consequences, but when we publish, there is no way to call it back, okay. When we invent, there is no way to come it back, it's becoming public. Identification, what can go wrong, must be associated with identification, what we invented. And everybody remember Einstein, and it's a very relevant subject for today, when you ask it, how will be the Third World War? And he said, I do not know. But I know exactly what would be the Fourth World War. Does anyone knows the answer?
Yeah, but
Okay, with sticks. We can still go to war, but with sticks. Okay, why do we have all these needs of knowledge? Don't ask me, because this is 4,000 years ago. It is the Epic of Gilgamesh. It was written on clay. Ceramics already have, but these are rock clay. Later on, some were fire clay. And it is the story that relates to our Noah, of a fellow dreaming. He did not know that he was in a dream. Often we dream, and our dreams, according to the Mazu, have some knowledge, but we should not rely on it, because it's sometimes ourselves fooling ourselves. But this is one of the last pages. He is trying to see what's after the mountain. Okay. And this mountain, the story is called the Twin Peaks. Why there? Because would we ever travel in space? Would we have intergalactic? Intergalactic would be very nice, but 56 years of flight to the next one is too much. 56 years or 56 million years to Andromeda is a bit too much, okay. So I put my question, if I have these locations, can I shorten the travel? Real, after all, seems that I will have less barriers of cube type. There are no bidimensional topological defects in space by the end. The author acknowledges that things we may have, barriers are not for other reasons. So, nowadays, people is still using general relativity to curvature of space to know if the dark holes can be, or dark holes in two places linked by the singularity can never be a place to shorten time or shorten distances. This picture I just put it there. But if I travel in a truncated space, or in a highly truncated space, I think I may save something from the tickets, and I'm closing. So I presented the sky, and I should have said that my master of the sky was my father, and the good weather of Lisbon, and the nice skies of Almada. Not in Aveiro, I think. Real summertime, July, at least when I grew, I remember where was the polar star and where was the big Ursa Major. These are still my points. It came to me where I was looking to this picture, and I said, I know this picture. Why? It is the Pegasus. It is the flying horse of the mythology. Okay. So it's just an invitation. If you have good capacity to, like the kids, to draw figures, this is a bear, that is another bear. If we go this direction, we will arrive to Pegasus, Mike Pegasus, and next to it we will have one of these galaxies that may constrain us. The lecture, that part of poetry was taken from that book. Kenji Miyazawa. The book was published after he died, but he has a very nice poetry text. The progress of Japan, the Japan of the progress train, the electricity were the novelties in the beginning of the 20th century. The book was a bit like João de Deus. It was prepared for the schools, and it gave me a lot of pleasure traveling in the train of the Milky Way. Why it has something that it is really a story of a kid, 10 years old, 6 years, 7 years old, traveling there, so all these Jules Verne-like descriptions, but much more simplified, with his colleague, schoolmate, traveling there. By the end, he wakes up, but the colleague was not there. The colleague did not came with him. If you read the story of Gilgamesh, it matches. He was just traveling, he went to another dimension, just like he was the kid that we are looking in the river, in this little festival there in his town. So it's a story of friendship, traveling in the Milky Way. And now I have one more reason to look to the sky, okay? And I must finish with acknowledging the very importance of Amelia, since I knew her, of the kids that grew from there, Mel, Brun, not anymore with us, and that should be in contact, but not at this moment, physical, and Marta that is here representing all. all of them. I think Amelia still remembers these pages. It's when a scientist needs an additional support. Lots of papers. First reported to Yvota and João and Brooke, and short of time because it was third month for me, or the 6 months report. And so I asked, can you at least, if you see there is two handwritings, put me here these pages ready, then I put my notes and, okay. Still nowadays, today I was not able to help in the cooking because I was preparing my last lecture for this, for you all. And I think I'm really in the last transparency, so I owe to all, to my family, to all of you, friendship and support and assistance. And this is the book I quoted. Let me go to a very old concept that never loses opportunity. And give me a second to see if I have memorized, if I still have some knowledge of Greek. Sorry, I'm lost. Okay, if you can read Greek. To sophan ante Sophia, to teme nata phronein. Okay, it is a very old non-Greek tragedy, Baksesh. Okay, Baksesh. It is from Euripides, with the detail. He died that year. Okay. It was published that year, okay, presented in Athens. And what follows that in the ruling of this democracy, you may well guess, it was the period of the 30 tyranns. And then came Philip and Alexander, and then came the Romans, and then came the Turkish, and then came many other things. But it has this particular. And I think that our language is even better than English to translate the Greeks, because if I say so, saber não é sabedoria, I think I capture much better the meaning of the sentence of the Greek poem than translating it. So Portuguese language still keeps that old sense from the past. But anyway, I have nothing else to say but that little thing by Sam, and inviting you all for a little port outside the Trui and my stories and the students. I must say that nowadays I have a very special bottle for the students of last course, because they were so enthusiastic with the professor and they were not buying me because I was just leaving the teaching. They offered me about in this room after my postermissima aula. That was a Latin mistake, postermissima classes. Thank you. Obrigado a todos. Um abraço. Esquecemos de falar de nada. Segunda-feira. Difícil de microfone.